cost of carbon is a construct. It is a dollar measure of the damages from one more ton of carbon dioxide emissions in any given year. And you can also do the social cost of methane, the social cost of nitrous oxides, NOxes. So the social cost of carbon is that measure of marginal damages that you would need for a Pigouvian tax. So Pigou's prescription is set the tax equal to the social cost of carbon, and so we could proceed with that sort of bit of advice to members of Congress. So of course, the question is, what is the social cost of carbon? And it turns out we don't really know what the social cost of carbon is. There are lots of estimates, and I'll show you one with these lines here. These are numbers from the U.S. Interagency Working Group, which starting in 2009 put together a process for developing numerical estimates of the social cost of carbon that could be used in regulatory analysis in U.S. government regulation for the regulatory impact analyses. And so what you see with this, these are numbers from the revised report that came out in 2015. So what they did is they got several big integrated assessment models. They got 3 of these models. They had different, they have distributions of key parameters like climate forcing. They have different discount rates because discount rates matter because a ton of carbon we put into the atmosphere today has impacts hundreds of years from now. So we need to discount those damages back to the present to get the social cost of carbon. They did Monte Carlo simulations to get whole distributions of estimates of the social cost of carbon, and then they ended up reporting essentially for every year 4 numbers. And so the 3 lowest lines here are estimates of the social cost of carbon in each year for a 5% discount rate, the lowest line, 3%, and 2.5%. And lower the discount, a lower discount rate means you're putting more weight on future damages, so you would get higher damages. And what they're doing is they're running these models. They add 1 more ton of carbon dioxide into the model. They crank the model. They see how damages change. There are damage functions in these models for each year, going out hundreds of years. Then they discount those back to the present, add them up, and that becomes a measure of the of the incremental damages from that ton of carbon. Now, the other thing they did was they reported a number for, well, let's look at the 95th percentile, sort of at the extreme end of the distribution of estimates for the 3% discount rate case. So this interagency process led to a bunch of estimates, 4 average estimates, actually thousands of individual estimates. But if you ask somebody, if you ask Senator Sheldon Whitehouse from Rhode Island, who would like to put a carbon tax in place where the tax rate's equal to the social cost of carbon, you ask him, well, which social cost do you mean? He's going to say, well, the U.S. one, the one from this analysis. And typically, there's kind of a Goldilocks phenomenon going on. Things are too hot or too cold or just right. Well, 5% is kind of low, 2.5% is kind of high. So typically, people focus on the 3% number as the social cost of carbon. Rightly or wrongly, that seems to be sort of where people focus. And so the numbers there range from about $30 to $70 between 2016 and 2050, if you look at those numbers. Now, if we set a tax equal to the social cost of carbon to these numbers, you would not get a whole lot of emission reductions. You would not get 80% reduction in emissions from 2005. That's, unless we have a magical invention of some new technology. We're simply not going to get dramatic, deep decarbonization. But that's what you would get with these estimates. And critics of this approach say these numbers are way too low. They're not really taking into account major climatic, catastrophic types of events. Maybe true, probably is true, but these are the numbers in the U.S. Interagency process. So a second approach you could take to setting the tax rate would be, well, let's have an emission reduction target and then set the price to make sure we get to those targeted reductions. So one might be just 2 potential targets. One is the the INDC, the National Determined Contribution, from the Paris Agreement last year, where the U.S. committed to 26 to 28% reduction below 2005 by 2025, with best efforts to get to 28%, to get to the high end. So that's what the Obama administration committed us to doing over the next 10 years, roughly. But then at the end of the INDC document, and if you look at other U.S. government documents, you see this as well, you see this aspirational target of an 80% reduction by 2050. So you can set that as a target if you want. Now, if we look at some scenarios, so this is some emission scenarios from a paper by 2 MIT economists at the Joint Program for Science and Policy Global Change, where they looked at a $20 per ton carbon tax starting in 2015, but the rate that grows at 4% plus inflation every year, going out until 2050. And they've got baseline emissions in the absence of policy. Top line, the middle line is just the carbon tax, and the bottom line is the carbon tax, as well as the continuation of the CAFE regulations that are in place, and will continue forward. So I'll focus on that bottom line. You see that in 2025, based on that kind of carbon tax, you get about a 20% reduction in emissions relative to 2005. So that's not so far away from the commitment made by the U.S. in Paris. A little tweaking of that, a little higher rate would probably get us to the 26 to 28% reduction. But we're way off the 80% reduction by 2050. In fact, someone was, I think it might have been Haroon was showing this, that some of the models that actually tried to estimate 80% reduction in emissions couldn't solve in the vernacular of integrated assessment model, and the models blew up. They just sort of chunk away. They can't find a solution. So 80% is quite ambitious. So a third approach could be a revenue target. There's a lot of discussion in Washington about a bipartisan kind of a coalition where we pair a corporate income tax reduction with a carbon tax. And the logic here is kind of nice because Democrats want a carbon tax, Republicans want reduction in corporate income tax rates. Actually, Democrats want that as well. There's sort of bipartisan agreement that the corporate income tax rate is too high. It leads to all kinds of problems, including things like corporate tax inversions and so forth. But when you try to do a corporate tax rate reduction, it looks really ugly if you try to fix it just within the corporate income tax. You end up having to throw out a lot of deductions that businesses don't want to lose. So you end up with a realistic proposal that's sort of short by about $100 billion, which is exactly what a $20 to $25 a ton carbon tax could do, is fill that hole by providing $100 or so billion a year to give you a revenue neutral tax reform. So there's sort of a revenue target for contributing to fundamental tax reform could be a way to think about setting the carbon tax. Well, with revenue targets, that'd be one approach. I need $100 billion or whatever you need. You sort of set the tax accordingly. The other might be to ask the question, well, how much can we raise with a carbon tax? What's our, if we wanted to maximize revenue from a carbon tax, how much could we get? And so the tax revenue is equal to the tax rate, tau, times the base, the tax base emissions, covered emissions. And if we just take a derivative to see how does revenue change as the tax rate changes, it turns out that there's a key parameter. So the answer is it's equal to emissions times 1 plus this thing, epsilon, which is the price elasticity of demand or supply of emissions, demand for emissions. It is the percentage change in emissions with a 1% increase in the tax rate. And this will be a negative number. If we raise the tax rate, emissions presumably would go down. At least they wouldn't go up. They may not change, but they wouldn't go down, probably. So if we wanted to maximize revenue, we want to go to the peak of this curve where the derivative is 0. And so that would occur where epsilon was equal to -1. A 1% increase in the tax rate leads to a 1% decrease in emissions. But if it turns out, so what is epsilon? Well, it turns out we don't have an estimate of that. We have we have estimates of the price elasticity of demand for fuels, and those estimates are all smaller than 1 in absolute value. They're all negative, but they're smaller than 1. That would suggest we could just keep cranking up this tax rate. We would just keep collecting more and more and more revenue. But the problem with that, of course, is it ignores fuel switching. We can switch from coal to natural gas. We can switch from fossil fuels to zero carbon fuels. And that would suggest a higher elasticity. So it's really not clear what that number is. But what is, I think, clear to me is that if you had really, really high tax rates, at some point you'd get what I'll call a punctuated equilibrium, which is that the pressure to come up with a high enough tax rate on carbon, the pressure to come up with cost-effective, zero-carbon technologies would be great, and all of a sudden we would find we're collecting revenue and emissions, new technology comes along, and boom, emissions go to zero, and we no longer collect any taxes. It's kind of happening with the excise tax on gasoline that funds the Highway Trust Fund as we move to more and more electric vehicles. Well, the last possible way to set the tax rate is to look at a political target. To set a tax rate to get something passed through Congress, and this is actually what will happen. We'll talk